So in the last video, I left off in that we return a 1 for whenever we find the particular element. To enhance this algorithm to also take into account the duplicates, what we want to do is to count the neighboring elements from this middle element. So to do that, we can do this with a for loop. We can start looking at all the elements that follow the x. So let's start looking at the next element, and we're gonna do this as long as we don't go beyond the length of the array. And we're also gonna do this only if what I have matches the element x that we were looking at. So if we do that, oh, I forgot to add here, we want to actually start with a count of 1 because this middle element x will be counts for one element that we have found, one instance of it. Now we're going to check if the next elements are also instances of this x element. So here we increment x by 1 every time we find an instance of the element. Now we are also going to want to do this for all elements that are previous to that middle element. So we start with the previous element, and as long as the index does not go beyond 0, which should point to the very first element, then we'll just keep decrementing and looking at the different elements that are previous to that middle element and see if they match x. Finally, we will return the count. So we're basically starting with a count of 1 for the first instance of the x element. We're looking at neighboring elements starting with the first neighbor. That means next to the middle. Then we go back and look at all the elements that are previous to the middle element and count for every single one that matches our x value. And this should basically cover the doing a binary search while taking into account duplicate elements. Did a little reformatting there, and let's see how it runs. And here's the instance of 5. It's just 1. 3 has 3 instances, 4 has 3 instances, 5 has 1 instance, and negative 1 has 0 instances. Now let's pretend that they're all 4s. Let's see if it still works with all 4s. And as you can see, it does work, but oh, we're off by 1. Oh, I think it's because I can actually be equal to 0 as well, so that should fix that problem right there. Okay, so now we do have that the correct count of numbers. So I believe this algorithm should work for doing a binary search that has duplicate elements. Thanks for watching.